Dear students, welcome again to fourth video of Unit 4. This video we will try to understand the concept of chi-square test. This video would be summed up wherein we will try to understand why do we use chi-square test, what does chi-square test shows, how do we calculate and interpret chi-square test, and when would we use it. I would like to explain the concept through an example. There was a school, and in the school, we wanted to choose randomly 20 students to find out a claim which was made by a school that the gender ratio in the school is 50-50. Here, we can substantiate the claim by choosing 20 students as a sample. Let us find that the first group of students chosen were 11 male and 9 female. The question arises, does it substantiate a claim that the male female ratio or gender ratio is 50-50? Second sample taken was 12 to 8. Third sample taken was 13 male, 7 female. Fourth sample taken was 14 male, 6 female. If you try to pose these questions to different people, you may get different comfortability with different ratios. What I mean to say is chi-square test is nothing but it is a valuation inherent variability from the data collected and data predicted. That is what we need to understand. From where hence we need to be very clear with respect to a concept which is called as null hypothesis. With respect to our example, null hypothesis is a claim and that is what is converted further into a prediction. If my claim is the gender ratio in the school is 50-50, prediction from the sample has to be 10 is to 10. But the data which I have got is 13 is to 7. So what is the prediction, or does it substantiate the claim that 50% of the gender are male and female? Let us try to understand that with a very clear concept of null hypothesis and alternative hypothesis. Null hypothesis, as you are aware, is a hypothesis that says that there is no statistical significance between the two variables. It is usually the hypothesis a researcher or experimenter will try to disprove or discredit. Alternative hypothesis is the one that states there is a statistical significant relation between the two. That means to analyze whether there is interdependence of variables, we would generally try to have a chi-square test conducted. Chi-square test or critical chi-square value is calculated by a formula which is given as summation, which is observed frequency minus expected frequency square upon expected frequency. With the same example which we discussed previously, let us try to move forward with respect to the formula which we have tried to analyze in the previous slide. Observation was from the sample of 20, there were 13 girls, 7 boys, while in case of expected it should be as 50% of the sample was 20 as sample was taken, 50% has to be boys and 50% has to be male. So if you want to calculate a chi-square value, we need to first step subtract observed frequency minus expected frequency. If you look at row 1, 13 minus 10 is equal to 3. Then we did a square of it, and square of it was divided by an expected frequency of 10. We got an answer of 0.9. Similarly for boys, observed frequency was 7, expected was 10. The first step we tried to subtract observed minus expected, whatsoever is the value, it is to be written as it is, whether it is plus or minus. In the second case, if you look at, it is written as minus 3, but the square will get converted into 9. So immediately the boys column last observation minus expected square upon expected also has a value which is 0.9. Means here chi-square value is 1.8. This calculated chi-square value needs to be compared with the critical chi-square value which is generally provided. On that basis, we can generally go for analyzing what is the value. If chi-square value is less, if calculated chi-square value is less than the value for 0.05 probability, we you cannot reject the null hypothesis, means you need to accept the null hypothesis. Remember, when a calculated chi-square value is less than or equal to critical value, you cannot reject null hypothesis. Please remember this in mind. And if calculated chi-squared value is more than the critical value, we need to reject the null hypothesis. That means we are going to accept the alternative hypothesis. This is the most important point, that in what case we are going to accept null hypothesis, in what case we are going to reject the null hypothesis. On rejection of null hypothesis, we would be accepting the alternative hypothesis. Just a recap of what we have done. Chi-square is a test of interdependence. Remember, which we are going to calculate. Whatever we are going to calculate is called as calculated chi-square value. And the value which is given in the problem is critical value. We need to compare calculated value with the critical value. The formula recap is summation of O minus E bracket square divided by E, whereas O is observed score or frequency and E is expected score or frequency. Let us try to understand how the problems would be generally related to chi-square test. Problem would be given in a form of a table wherein you can see rows and columns. If you look at 1, 2, 3 is rows and C1, C2, C3 are written as column. The summation of row, that is column row, in a row, summation of C1, C2, C3 is equal to R1. That is what we need to, and summation of the column would be at the bottom where C1 is written. We need to add all C1, C2, C3 and calculate N. We are going to get observed value which is given in the table, and we need to calculate the expected frequencies. Be very clear. Step number 1. What all would be available? Let us try to understand that with the help of example. This is what is the question, the table given, wherein if you look at, in rows, marital status is given, never married, married, divorced, widow, total. And in column, educational qualification is given, like middle school, high school, bachelor, masters, PhD and total. What we are trying to find out? We are trying to find out that whether is there any relationship between marital status and qualification, marital status in rows and qualification on the qualification in the columns. Is there any relationship? So what could be the hypothesis? Hypothesis stated are null hypothesis, there is no relationship between marital status and educational qualification, and alternative hypothesis is there is a significant relation between marital status and educational qualification. This is the data which is available. Also, the critical chi-square value was given in the table. We will discuss it later on. We don't need to calculate now. The values are generally given in the generally available. If not, we'll try to find out high. Remember what we have? We have rows where we have marital status. There are 4 rows, and in column you have 5 columns which is having different qualification talked about. So in first step, whatever was data given in the problem is taken down. Step number 2, I have stated hypothesis. There is no relation between two variables row column. There is significant relations between two variables in one in row and other in column. In the next step, we will try to calculate the expected value. If you look at the observed values were procured from the data which was given. In case of expected value, we need to create a same table. But in case of column, the values should be calculated. For example, if 18 is the value which represents marital status as never married and educational qualification as middle school, this is observed value for never married and middle school. If you want to calculate expected value, please go to the end of the row, that is 90, end of the column 39, end of the column at the bottom sum 300, that is what is the sample size. This column at the end where 300 is written is nothing but a total sample, that is what is n. If you calculate, you are going to get 11.7. Let us try to understand that for high school, and the other are calculated for your understanding. You just write down on a piece of paper, calculate for your understanding the rest of the values and put it in a table on the paper you are going to do it. If you look at second, high school, what is that? High school is educational qualification and marital status is never married. For them, observed is 36. Means what I need to calculate? I need to calculate high school. What I'm going to do is end of the row 90, end of the column 90, end of the total column 300. 90 into 90 by 300, expected frequency for column high school as a qualification and marital status never married is 27. Likewise, we are going to calculate the expected value. Just have a recap. Step number 1, I took the table as it is given in the question. Question does have a critical value given. Third part is I have stated hypothesis, both null hypothesis and alternative hypothesis. Then I calculated the expected frequency for all the observed frequency which was given in the table. That is what I have done as a third step. Fourth step, I will try to calculate chi-square. If you remember, calculated chi-square is given as summation O minus E, that is observed frequency minus expected frequency, bracket complete square upon expected frequency. So whatever was available, I have tried to put them into a column format wherein the first row is observed value, second is expected, third is O minus E, fourth is O minus E square, and last one is O minus E square divided by E. If you take first row where observed frequency was 18, expected frequency we have calculated in the previous table was 11.7, we concluded it that it is 6.3. O minus E square, that is 6.3 square, goes to 39.69. Then we have calculated O minus E square divided by E, that is 3.39. Similarly, you need to do for all the observed frequencies available in the table. All the frequencies, you cannot skip a single one. Last column needs to be added, summation, all which we need to add, and you get a value at the end. In this case, the value we have calculated is 23.57. That means at this stage I have calculated a calculated chi-square value. Once I get calculated chi-square value, the degree of freedom can be calculated, which is generally given, but let us try to understand. We had 5 columns, minus 1 is to be done, 4 rows minus 1, that is 4 into 3, 12. And we discussed previously that it should be 0.05 is what is degree of freedom at point zero 0.05, that is significance level of probability, that is what we have calculated. From 12 and point zero 0.05, 12 in the row and 0.05 in the column, find out an intersection. You will see to it, you will get a critical chi-square value, which is stated here as 23.03. Now from this table we have calculated both. What both things we have calculated? We have calculated the chi-square value, and we have also obtained a critical chi-square value. Here we have tried to calculate a critical chi-square value, but the problem generally asked today does not need to calculate that. The values at point zero 0.05, that is significance level of point zero 0.05 values, which is called is critical values, are generally given in the problem. So on comparing, let us try to understand what we can do. If you remember, calculated critical value was 23.57, which we did by our own calculation. Critical value was given in the table was 21.03. What has happened? Calculated value is less than the critical value. Calculated value is less than critical value, which means calculated value is less than critical value. We reject the null hypothesis and we are going to accept the alternative hypothesis. That is what we need to put across. Calculated value is more, 23.57 is more than critical value 21.03. That is the reason we have rejected null hypothesis. Hence, as we have rejected null hypothesis, we have accepted the alternative hypothesis, and we have returned an alternative hypothesis that there is a significant relation between marital status and education. This is proved through chi-square test. This is how we are going to analyze some problems, some practice problems on chi-square test for understanding. Thank you.